Hello, Earth Science. I just want to take you through a couple pieces of this porosity permeability relationships paper that we're working through today. So one of the things you should know about this is that sometimes in the questions they'll refer to particles as beads. When I first started teaching, and I'm sure this is still happening in some places, there was a lab we would do with plastic beads where we would pour water into them and measure the pore space, and we would also run water through them and measure the porosity. But as time went on, a lot of teachers started using actual sediment. Otherwise, students were confused about what we were actually demonstrating here. So in this first part up here, the first three questions, they're just asking questions about relationships and really definitions here. But number 3 says, how does the pouring of water into a beaker of beads tell us about the total pore space? So remember, I shared this with people who were in class, but if you weren't, to measure porosity, the best way to do that is to put a bunch of particles into a beaker, a graduated cylinder, and then close off the end of it so that no water can leave, and then pour water into it, keeping track of how much water you pour in so that you can measure how much water it took to occupy that pore space. So really it's a measurement of volume, and you're just using water to occupy that volume. This part here too with the graph, it says porosity is independent of grain size as long as samples have the same volume, shape, and packing. So what they're looking for here is porosity versus particle size. And they have sorted versus unsorted. You don't need to do 2 lines for this one. You can just keep it simple. And please keep in mind that there is a direct relationship between particle size and, I take that back. There is no relationship between particle size and porosity as long as they have the same size particles and as long as they have the same shape and the same packing. So this one here, your graph is going to look like straight across with no relationship there. Now the next part here says porosity depends on shape. Rounded particles has higher porosity than angular particles. So this one here, the percentage of porosity, you don't have to come up with a number. Instead, we're looking for like high, medium, low. What goes into those spots. And then down here, loosely packed particles have more porosity than closely packed particles. For this one too, we're looking for high and low. Checking to see if there's any problem points on the next page. I sort of think at this point it gets much more straightforward. Yeah, we're good here. The only time I think it could get tricky is here where it says time, how long it took. This is, I'm on page 3 now, sorry. It says time, how long it takes for something to happen. They have time and rate. Rate is how fast something happens. And they want you to rank these up here down below. So they give you A, B, C, and D, and they want you to fill those in on these lines. Sometimes students get a little confused about what am I actually putting here? Like numbers or what? No, it's these letters from up top here. And capillarity, the last part here, the ability for water to travel upwards through the soil. Number 2 says, what is the major factor that affects the force of capillarity? There's a couple different ways you could approach this question. So number 1, you could say particle size. We covered in class how smaller particles offer more surface area for the water to rise up on. Or what's actually the driving force behind capillarity is transpiration. Plants pulling water out of the soil is the force that's actually pulling them up, and the particles in the soil give them all the surface area to cling on to. So either answer for that one will work. So you can keep it at the sediment level, or you can take it from a bigger picture and say, well, a lot of what's driving capillary action is plants pulling water up through the soil. So a couple different ways you can go about that one, but no need to spend 10 minutes Googling an answer. That's going to be much more straightforward. So the rest of it should be very direct, and I don't think you have any questions for the rest of it. There's a few of the points I wanted to clear up. Again, porosity, permeability relationships looks like this. Should be the one you're working on today.